One other thing that the total station will need to orient itself, we've talked about giving it its position coordinates and then the direction, that the bearing. But there might be cases on site where you may not have a coordinate actually to set the instrument on, or a point to set the instrument on. Maybe the points are on a wall or something. Site condition might force you. I've encountered that a lot of times where site condition forces you to put controls on the wall. So maybe you have three controls, 3 points of known coordinates on the wall, and you want to use it to orient the total station. In that case, you have to go by what we call resection. Resection. How that resection works? How does it work? So you have one point on this wall, another point on this wall. Let's say A and then B. Okay. You set the instrument somewhere, maybe at C. Okay. Then you input these two coordinates because you know the coordinates, northern and eastern. That's X, Y. If you have the Z, you are doing height. You are working with heights too. You add the Z coordinates. Okay. So you enter the coordinate for A, you enter the coordinate for B in the resection function in the total station. There's also will ask you observe to A, observe to B. Okay, this is what the total station will do. It's going to form this triangle. Okay, will form this triangle. Okay, now the total station is able to measure this angle alpha, okay, and measure D1 and then D2. Okay, as for D3 here, it's already known because these two coordinates are known. So you remember we did the Euclidean distance, we were able to calculate the coordinates between the distance between 2 points if the coordinates are known. We've done that already. So it's able to calculate this one. So it just needs this angle because it knows this bearing as well. It knows this bearing. Okay, so it gets this angle it needs. It adds this angle to this bearing. It gets this bearing. As well, it gets this bearing. It knows this distance, so it can calculate the coordinates of this. So it uses the sine rule, the cosine rule, sorry, to calculate this angle. It gets this angle, it adds it, then it can get this coordinate. As soon as it gets the coordinate, it can now orient itself because it knows the coordinate, it knows any of these, it knows this bearing. So calculate the coordinates, any coordinates in the space. That's what it does. Okay. So we use the cosine rule, which says that D2 squared is equal to D1 squared plus D3 squared minus 2 D1 D3 cos, let's say this alpha, cos, no, this is beta. It's beta we want, cos beta. You use this formula, then it makes cos beta the subject, then it's able to get beta. Because it knows D2, it knows D1, it knows D3, so it's able to get cos beta. As soon as it gets cos beta, adds it to this bearing, it has the bearing for AC, and that's all. It's good to go. It's able to calculate the coordinates, orient the total station, and then calculate all the coordinates that it needs. Now we will learn a few things about the total station. The instrument itself. I'll also go to the field to just demonstrate. After I'll go to the field to go and demonstrate. The total station has two circle reading. The horizontal circle reading, okay, and then the vertical circle reading. So when you if you look at it planimetrically, this will be the horizontal circle reading. If you look at it by the side elevation, this will be the vertical circle reading. The telescope is like this. Okay, the telescope is here. This is the center of the telescope. Okay. Okay, so as you rotate about the horizontal, the angle changes. The same way as you rotate the additive, the angle changes. So that's how it's able to get the angles. So it's able to take angular measurements, okay, and then use to compute. So the angular measurement is the same as the bearing. Take the bearing for angular measurement, and then it takes the horizontal distance from the EDM measurement. It's able to compute the coordinates of points. So that's basically how the total station works. Now, what are some of the things we do on site with the total station? We do setting out with it. We learned about the level. Now, the total station is more superior the level because it's able to set out points in both the horizontal and vertical plane. So what are some of the things we use it to do on site? We use to transfer controls, that's coordinate of points on the site based on the established site grid. There are different coordinate systems where you can set out a site grid. You can establish a site grid that is specific to that site alone, and then use the total station to coordinate points. Now, you can use the total station to do an as-built of the construction stage, where we want to find out some of the things that might have gone wrong or any change that must be done on the total station. You can use it to do what we call an as-built. Pick points, plot it in AutoCAD Civil 3D, and then you check out any disparity or anything. Then you make decisions on changes or what you do going forward with the construction. It's also used to set out points. So you can use to set out kicker points for column positions, either the column centers. So when you are doing the footing, the center of the footing, the center of the column, or the four corners of the column can be used. You can use the total station to set this out to guide the setting of the iron rods, starter bars, before concrete is poured. And as you go up, you can use it to set kicker points on the foundation floor. It can also be used to set out the level. If you want a level oversized concrete floor, the total station can help you to set it out like a level. It can also help you to do that. It can also help you to set out drains. So with that, you don't even need a tape. All you need is to input the coordinate of start and finish. Use a line function, or we call a line function. Then you can set out drain invert at a certain slope, like the design slope. You can also use it to set out grade lines on site. So maybe for a small building, you want to do a profile around, a wooden profile around the building that will have all the grade lines. So you can pull ropes, you can pull lines, okay, to mark out walls, mark out excavation lines and all that. You can use the total station to set the centers of all the grade lines on the wooden profile board, and then from there you take it, you continue, and that will make sure the building is square, properly squared. And one thing that I want to talk about is the line function in the total station. The line function is very useful for construction, because mostly in construction, all lines are either parallel or perpendicular, and the line function will help you do that. If you take a building, for instance, all the building walls, every wall is parallel to another wall or perpendicular to another wall. So it helps you to set out all the walls, all the components. If it's height, it can even help you, maybe lintel height and all that. It can also help you to do it. So that's what the total station does. A very powerful machine. Another thing it can also do is, you want to set out a warehouse and it has a long span. With that long span, it will be difficult to use a normal square to get everything right. The total station can be used to set out the centers of all the columns, so that everything probably prefab is coming to sit on the foundation. With that, everything will be in place. By the time prefab comes, based on the design, everything will fit perfectly. So that's how useful the data station is. We'll go on site and then we'll see how it is used. Thank you.